Hi, everybody. So, if you have ever tried joining track and field or running, or you know anybody that has ever run track and field, this is a really interesting question to that I always had about it. Like, how do they position the players such that it is fair for everybody? And then watching the Olympics, I noticed, that since the tracks were a little bit elongated, like on one side and then on the other side of the field, and then they had like a semicircle here and a semicircle here. Well, the person who starts, let's say they're gonna run this way. The person who starts here is gonna take shorter to go around this semicircle. The person who starts here, if they start the same one, it's gonna take them longer and so on. So that is an interesting one. So obviously this person needs to start a little bit more behind. So what angle does this need to be, or how far behind does it need to be in order to compensate for the shortness that will happen here and the shortness that will happen here as well? All right. So let's see what does the and is it fair and how do we calculate that? Depending, do all tracks follow the same one or is it just only certain tracks? So let's go into this problem. So here's the problem. So we have two runners, one is in lane one and one is in lane two, and they want to stay as close to the inside as possible because that will be the shortest distance for them to travel through. All right, so we want to know how much longer is one track from the other one if they in fact decide to run along this particular line. So let's see. Ready? So in your marks, get set, and run. This one trip is coming. This one stop. This one is going. Stop. Stop. And let's continue with the problem, and then we'll continue with the race. Things to notice. So inside the track is 33 meters from the very center all the way to the very inside of the very first lane, lane one. And on the outside, well, if it's 1 meter, look at the information, 1 meter long between the tracks. Well, if from here to here is 33, from here to here must be another meter, right? So it's 34. So the outside track has a radius of 34. What do we say radius? Because we're going to grab this baby here and we're just going to rotate, rotate, rotate until we end up here. So let's see. Both tracks are semicircles with central angles of 180 degrees. Look, whether it's the first track or is the second track. Who was winning? Let's see. And let's continue. The arc length. This is the formula. How to calculate arc length. That's essentially what we're interested in finding out here. How much longer is lane one from lane two here. Ooh, let's continue. So this is the formula. Write it down. All right. What is it saying? That the arc length here is going to be equal to the radius, whatever radius. If you're talking about a little track, well, that's your radius right here. If you're talking about a longer track, well, then this is your radius. It doesn't matter what radius, all right? The length can always be calculated. This little arc length can always be calculated by substituting r and substituting theta. What is theta? Well, theta is the portion of the central angle that we are interested in calculating. In this case, our angle, since we're going all the way from here all the way to here, because our track ends right here and ends right here on the end, so we want to calculate theta being 180 degrees. Let's see in this case, what is the math? What is the math? What is the math? So what's the math? Here is the math. Lane 1. Lane 1, the radius is 33, so the length of the arc is going to be radius times theta. And in this case, we have 33 times pi, right? Why is theta? Theta is 180 degrees, but we know that 180 degrees is equivalent to pi radians. So theta is pi radians. So let's use radians in this case. So 33 pi, you know about pi. It's a transcendental number. It's not even, some people call it irrational. It's a transcendental number. All right, but that is pi. So, and we do this. Remember how we did again DMS and just degrees? The pi, that 3.14, blah 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 blah. That is really important. That can make a difference if we're talking about very precise calculations. So when we're talking about angles and measurements and stuff, we actually like to use radians as a unit. After all the calculations, we get that the arc length is equal to 103.6725 meters, or you could say 33 pi radians. And this is how we calculate the length of the second arc, lane 2, right? The inside of lane 2. And it turns out that the difference between the one is 34 pi, right? That was the second lane, minus 33 pi, which was the arc length of the innermost lane, for a difference of pi, which is approximately equal to 3.14 meters. So what does that mean? That means at the very beginning where they're gonna start, this second person should start pi away. Here is the first person, and the second person should begin pi units away if the tracks were 1 meter away, and these were the measurements, 33 and 34. All right, so let's see, who do you think won the race, the inner or the second one? And oh no 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 ah, and fireworks, yay, confetti, awesome. And this problem actually gets very interesting. We're talking about swimming versus track and run and all this stuff. Swimming is just back and forth, back and forth, back and forth. All right. But in track, when we're talking about track, how many times is it going to go around the track? Because we need to subtract the difference for each of the times. Are we just going to go around only one? Is the race length only around once, or is it going to go around twice? Also, are the players, are the runners allowed to change tracks? If they're here, are they allowed to change tracks into this one? Because if such is the case, how do we compensate for where they're going to begin to make it fair for everybody? Everybody's going to try to run into the center one to minimize their distance. All right, so how far do they begin? Have you ever thought of that? Let's make it fair for everybody. Da, 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 da. Yeah. So angular speed and angular distance, that's another concept that has to do with angles and radians and all this stuff. But yeah, so this is how we do this problem.